Leetcode problem 855 exact room. So for this problem, let me first try to explain it. So let me just make a drawing. So we are having an exact room with n seats in a single row labeled from 0 to n minus 1. So that means the label gonna, so this is so for example, this gonna be the room, and this gonna be a row, and they're gonna be the labeled from 0 to n minus 1. Yeah. So when a student enters the room, they must sit in the seat that maximizes the distance to the closest person. So for example, if here, so definitely if here is a person, he's sitting here. So what gonna be the next person, here or there? Definitely it's gonna be here. Yeah, because this gonna be the maximized distance. Yeah. Now let's just continue. If no one is in the room, then the student sits at seat number 0. So currently, if there's no one in the room, so the student will be here. So the student will be here in the index 0. Yeah. Now we're gonna design such kind of class. So it is called exam room, and yeah, there are gonna be two methods. So exam room is gonna be initialize the object of the exam room with the number of seats. So it's gonna initialize with the number of n seats, and the seat gonna return a label of the seat at which the next student will sit, and the leave indicates that the student sitting at seat P will leave the room. It is guaranteed that there will be a student sitting at seat P. Let me first use let me use the first example to explain, and after that we're gonna find a method to solve the problem. Yeah. So currently, let's just initialize the room. So the size is gonna be 10. So this means the index is gonna be from 0 to 9. So this means the size is 10. And first of all, we're gonna call the seat. So first of all, because there's nobody inside of the room, so the student will sit at here, at index 0. Yeah. Now we're gonna call another seat because we want to maximize the distance. So the next index is gonna be 9. So here gonna be a student. Yeah. So what's gonna be the next? We're gonna still call the seat. So it's gonna be in the middle. But in the middle, we're gonna close to this 0. So we're gonna choose index 4. So index 4 here gonna be a student. Yeah, even though here the distance is 4 minus 0, here the distance is 9 minus 4. It is bigger, but for us, we're gonna choose index 4. Yeah, because according to yeah, return the label of the seat at which the next student will sit, and yeah, we can read it from here. If there are multiple such seats, they sit in the seat with the lowest number. So this means for this student, 4 and 5, both of them should be okay. Yeah, because for 4, here distance is 4, here distance is 5, and for 5, here distance is 5, and to the right the distance is 4. It is okay, but we will always choose the lowest number. That means we're gonna choose index 4 instead of index 5 for this example. Now what gonna continue is we're gonna still call the seat. So here, yeah, the distance is 4. Here the distance from 4 to 9 is 5. But we're gonna choose the lowest number. Next, we're gonna choose index 2. So instead of index 6. Yeah, even though we can choose index 6, we might think better. Here is the distance of 2. Here is the distance of 3. But for us, for our algorithm, we're gonna always choose the lowest number. So this means we're gonna choose index 2. Yeah, maybe you think this is strange, but while you check the example, it is like that. Yeah. So according to this, you have to design an algorithm to find it. So instead of using index 6, you have to use index 2. Yeah. I know this is not good for the problem, but they didn't tell you about that. You have to guess. So it must be this index 2. Yeah, even it told you it's gonna choose the lowest number. But why this index 2 gonna be the lowest number? We know that index 2 and index 6, 2 should be lowest number. But for this index 6, as you know here, gonna be a distance of 2, here gonna be a distance of 3. Maybe this is better, but the problem didn't tell you about that, so you have to guess it for yourself. Yeah, otherwise you cannot solve it. Now we're gonna call this leave. Yeah, and the leave is for this index 4. Yeah, so yeah, so for the next, we're gonna call a leave with index 4. So this means here the student will live at this place, and then we're gonna call this seat. So the distance is from 2 to 9, and this is gonna be bigger. Yeah, so for this distance, 9 minus 2 is 7 divided by 2, it's 3, 2 plus 3 is 5. So it means, yeah, it's gonna have an index 5. Here the distance is 3, here the distance is 4. We're gonna always choose, yeah, the lower distance, so it's gonna be 5. It's gonna be here. Yeah. So this is our problem. So according to this, we have to find an algorithm to solve the problem. So what kind of algorithm we can use? Can we use array? Yeah, because for each of the time we need to prepare a seat, and the seat is gonna be the index. And as we also know that if the seat is sorted in increasing order, it's easier for us to check the distance. So that means we're gonna use a sorted list. So it means every number, it is the index, it is the seat number 0, 2, 5, 9. It's gonna be a sorted list. So in this way, we can remove it easily. We just call a leave. For example, we're gonna leave this index 2. Yeah, and next, if we are going to call this seat, we just need to check the distance again. Maybe here the distance is bigger, we just put this seat 2 inside. So this is our idea, and this is also why we're gonna use a sorted list, because it's easier to leave, and it's easier for us to check in a sorted list. Yeah, to check all the distance. Now let's try to define a sorted list. But before we use it, we have to import it. Yeah. So import. So we're gonna from sorted containers, because it is inside the sorted containers. So we're gonna import the sorted list. Yeah. Now let's just define our sorted list, and we're gonna define this self.n gonna equal to n. Yeah. So for this leaf method, it's gonna be easier because we are using sorted list. We can call it directly self.sl dot. Yeah, we can call the remove with this p, because the p must exist. So we're gonna just leave it. So what about the seat? We're gonna check. If not, self.sl. So this means there's nobody sitting in the room, so we just add it, right? We're gonna add this 0 index, and we're gonna have a return of 0. Now we're gonna prepare the div and the index. So this just means the distance. So from the beginning, we are not sure about the div. Yeah, but here, at least there will be one person inside of the room, because if there's nobody inside, we're gonna insert this index 0 just inside. Yeah, maybe there's not index 0, maybe index 2 or 3, it is also possible. But for this div, we need to first find the first distance. So it's gonna be the self.sl if there's somebody inside. Yeah, we just set it to the left side. So we're gonna use the self.sl 0 minus 0. So we're gonna use the self.sl 0. We just prepare maybe the first person. So for example, this is the room. Maybe this is the only person here. So we're gonna set a distance of 2 from the beginning. Yeah, 2 minus 0 divided by 2, it's gonna be 1. The distance 1 from the beginning maybe. Yeah, we are not sure, but we're gonna set a value. We have to set a value. Instead of 0, we're gonna set it to be self.sl. Yeah, we're gonna set it as self.sl 0. And for the index, we're gonna prepare it as 0. Yeah. Now let's just pairwise all the distances. So for AB in pairwise with the self.sl. Yeah. Now we are going to check the distance. So the distance is gonna be B minus A divided by 2. Yeah. So if this is more than the div, so what's gonna happen is we're gonna update the div first. Yeah. So it's gonna be B minus A divided by 2, and we're gonna check the index. It's gonna be A plus B minus A and divided by 2. Why use this formula? This is because according to the description, it is always close to the lowest number. So we're gonna use this index. Yeah, maybe we can find this index or maybe not. But what if there's nobody in at the state 0 n minus 1. If it is not inside the self.sl, and if the distance n minus 1 minus the last distance is going to be self.sl minus 1. Yeah, the last person inside the room. It may be the last person is maybe nobody is here. Maybe the last person is here. Yeah. So this means we're going to use the last distance from here. This index 9 minus this distance. Maybe it is bigger, so we're going to update it. Yeah. Maybe this is bigger than the div. Yeah, because this is exactly the distance. So we're gonna update the div. So it's gonna be self.n minus 1 minus the last person inside the room, and we just put it inside self.n minus 1. Yeah, let me just update the index. So the index is gonna be self.n minus 1. Yeah. So at the last, we're gonna put it inside the sorted list. So self.sl gonna add this index, and finally we're gonna return the index. This is just according to the question. We're gonna have a return, and the return gonna be the person, and gonna be this index. And before returning it, we're gonna put it inside the sorted list. Yeah, I think that's all about it. It's definitely not a difficult problem. Now let me just run it to have a tag. Yeah, now as you can see, it works. Yeah. So here from the beginning, we're gonna define an initial distance. So this is really important. So do not forget to define this initial distance, because if you don't define it, maybe you're gonna set it as 0. It's gonna be wrong. Yeah. So for example, if you set it maybe, yeah, you don't know, you just set it as a 0. As you can see, it didn't work. Yeah. So you have to set it from the beginning as the self.sl 0, because maybe we didn't execute from here, but this is self.sl 0, we're gonna reserve this value as a div. Maybe this is not even more than the div, but we're gonna use this index, and we're gonna directly put it inside. Yeah, so this is why this is really important. We're gonna find the first div. So according to this first div, if it is too bigger, we can directly put this. Let me think about it. Yeah. So maybe inside there's index, for example, 3. There's only this person index 3, but we need to prepare on this div, and this is going to be the distance. It's going to be 3 minus 0. It's going to be 3. So this is what inside 0 and 3. Now we are going to check the pairwise. Because the distance is 3, this is 3 minus 0 divided by 2. It is no more than div. Yeah, so we will not update it. So it means, yeah, it means if somebody were to go inside the room, definitely it will not be here. Yeah, because here is a person. Maybe here is 7. So for example, 7 minus 3 is 4. It is more than div, and then this guy will be here. Yeah. So what if this is not 7? Maybe here is 5. Yeah, but here is nobody. Here is empty. So it will be like this. So here is empty, but here definitely there's a person, and here there's a person. So what happens is that currently we are going to check if it is empty, but it is not. So we're gonna prepare this div. So this div is gonna be the self.sl 0 minus 0. It's gonna be 0. So currently the div will be 0. So this is okay. Yeah, because it's gonna be take the first one. It is 0, right? Yeah, it is 0, it is okay. Now we are going to check maybe here in this position, 3 minus 0 divided by 2, so it is 1. So the distance will be 1. We're going to check the distance, the difference is going to be 1. But here the difference is going to be 2. So this means for the next person, it will be here. It will be this 5. Yeah. Now we are okay. We have a person at index 0, 3, and 5. It is okay. Now, next, what are we going to do? We're going to call a leave. So what about we're going to call leave 0? So if we are going to call this leave 0, definitely here's nobody. Yeah, here is nobody. Now, what we are going to call? We are going to call this set. Yeah. So what's going to happen is, if we are going to call this set, this is okay. If there's nobody inside, so we're going to add this person as a 0. Yeah, so this person will be here. This is okay. Yeah, but for this difference, it's difficult to me to explain. Yeah, definitely this should be 0. Let me just yeah, I think let me just explain it once again. So currently here inside of the room there is this person 3 and 5. At index 3 and 5 there are there are some people. So now we are going to call this set. If this is empty, we're gonna add this index 0. But currently it is not empty, right? Because there's somebody inside of the room. Definitely we will not use this index 0 at the moment. Yeah, because we are not sure if this is better. So maybe, let me use another example. Maybe there's a person 2. There's a person 2 here. There's a person 2 here inside of the room. Maybe it is like this. Yeah. Here is the person 2, here is the person 5. So what are we going to do? We're going to call this diff. So the diff will be the distance of 2 from the beginning. So we are going to check, yeah, some positions we're going to be bigger than 2. So can we find some can we find some positions bigger than 2? That is not possible. Yeah, because this example is not okay. Yeah, so this means I have to use a better example. So it has to be 3. Yeah. So at this position there's a person at index 3, another person at index 5. Now the diff is that self.sl0. So it means it will be a distance of 3. Now we are going to pairwise. So this is 0 and 3. It's no more than diff, so we will not update it. Yeah, I think I need to use the third example to explain. Yeah, so what if I use a 0? Yeah, so as we can see, it is wrong. Yeah, now we're gonna use this example to explain. Yeah, so this is the room, and it will be initialized from the index 0 to index 8. So this is the room. Yeah. Now we are going to call the set. So from the beginning, nobody inside. So at the index 0, there's a person at index next. It's gonna be index 8, and next it's gonna be sorry, this is the index 7, not 8. Yeah, now it will be at index 7, and next it will be at index 3. There will be a person. Yeah. So next we're gonna call leave. So if we are going to call leave, inside this example, it's gonna be leave 0. So we will call leave 0, and next we will call this leave 7. Yeah. 0 and 7. There will be no person. This is a 0, and this is a 7. Yeah. Now we are going to call this set. Yeah, so if we are going to call this set, it's gonna be 7 because the distance is bigger. Yeah, so here will be a person. Yeah. Now we are going to call another set. So instead of 5, it's gonna be 0. Yeah. So it is not between 3 and 7. It's not this 5. It should be this is 0. So this is why we cannot set it as a 0 from the beginning. Yeah. So if we set it, the difference is yeah, so this means the next person gonna be at index 0. If we are going to set it as index 0, the diff will be 0, and we are going to pairwise. If we are going to pairwise, because there's no 0, so definitely we're gonna insert this index 5, and it will be wrong. Yeah. But currently 0 is not inside. So we will set the difference as 3. Yeah, so the difference we will set it as 3. So 3 is bigger, definitely. Yeah, so currently the difference is 3. And our index, we're gonna set it as 0 because we are going to check this index. We're gonna find some distance which is gonna be bigger than 3. Can we find? So from here, 0 to 3, it is no bigger than 3. 3 to 7, as this 7 has already taken, we cannot use it. We're gonna find somewhere in between, maybe this 5. So the distance is 2. 2 is no more than 3. So definitely that is not possible. So finally, we're gonna just use this index. It's gonna be 0. Yeah. So this is why. Yeah, we're gonna design on this kind of a pattern. So the diff gonna be a bigger value. It's gonna be self.sl with 0. It's gonna be a bigger value. So this means if there's no distance more than the diff, definitely we're gonna use this index 0. Otherwise, we cannot use this index 0. So this is the difficult part, maybe, yeah, for this problem. Now let me just submit it to check if it works. Yeah, as you can see, it works, although the speed is like 3 seconds, but I think it is okay. Yeah, so this is the difficult part for the problem. Yeah, I think that's all for it. Thank you for watching. See you next time.